So far, we have learned about self-attention, where each word in a sentence tries to find its relationship with all the other words. In an encoder-only transformer, the process starts with word embeddings, where words are converted into numerical form. Then positional encoding is applied to capture the position of each word in the sentence. After that, self-attention is used to determine how words relate to one another. The output of this step gives us contextual understanding, meaning the model knows in what context each word is used. This is the basic working of an encoder-only transformer, which relies entirely on self-attention. Now let's move to a decoder-only transformer. The initial steps are similar. It uses word embeddings and positional encoding as well. However, the main difference lies in how attention is applied. Decoder-only transformers use something called masked self-attention. This masking mechanism is what sets models like GPT and ChatGPT apart. In regular self-attention, every word can look at all the other words in a sentence, both those that come before and those that come after. For example, if we take the word eat, the model finds relationships between eat and every other word in the sentence, regardless of position. Masked self-attention works differently. When calculating attention for a particular word, the model only looks at the words that came before it and the word itself. It does not consider any words that appear after it. This ensures that the model can predict text in a left to right sequence, just like how we read or write. So, in masked self-attention, if we are focusing on the word eat, the model looks only at eat and the words before it, completely ignoring anything that comes after. The next word's attention value is also computed in the same way, only based on the words that appeared earlier in the sequence. This approach is what allows decoder-only transformers to generate text. They read everything up to a certain point and then predict what comes next. For example, if the sentence is, "The pizza came out of the oven," and the model first processes all the words up to eat. Then, using masked self-attention, it predicts the next likely words, such as tasted good. That predictive behavior is what makes GPT models generative. They generate one word at a time, each based on the previous context, without ever seeing the words that follow. To summarize, encoder-only transformers use self-attention, where every word can attend to all others, both before and after. Decoder-only transformers, on the other hand, use masked self-attention, where each word attends only to itself and the words that precede it. This masking makes generation possible, allowing the model to predict the next word step by step. I hope this concept is clear for you.